Hey guys, welcome to today's class. Have fun.
Good afternoon, everyone. I want to welcome you to mathematics class. And the topic before us is number base. So I will be using some exercises to explain what number bases are because I believe in your SS1 and your SS2 you must have been taught number base, and majority of these things won't be new to you. So my job here is just to give you more exercises and more questions to solve and explain how to solve them and exercises to practice. So let's go. So these are the basic key points you need to know whenever you want to solve number base. First, you need to know how to compose your number base. You should know that every number that has a base must start from zero. It starts from zero and ends on b minus 1. B minus 1 meaning if the number was in base 10, it means every number within base 10 ends at 9. It must not it's if it crosses 9, then it's no more in base 10, it's in another base. You need to also know that the number this in base b means 4 times b raised power 3 plus 1 times b raised power 2 plus 3 times b plus 2 times b raised power 0. What I mean by that is if this is in base b, if this number is in base 10, it means this is 4 times 10 raised power 3 plus 1 times 10 raised power 2 plus 3 times 10 plus 2 times 10 raised power 0. And I want you to also note that anything raised to power 0 is 1. I don't want you to forget that. So I want you to also know that whenever you are dealing with decimal point, a number in base b that has decimal point, it means 5 times b raised to power 2, 7 times b plus 2 times b raised to power 0. So plus, because of this point, this 4 becomes minus 1. 4 times b raised to power minus 1 plus 3 times b raised to power minus 2. You might be wondering where I got the power of 3 or the power of 2. We are dealing with bases. Sometimes you can't like this. Probably you can't from like this. When we were in secondary school, this is how we do it: 0, 1, 2, 3. So since we usually start from 0, like it was written from the first key point, then it ends at 3, and there are 4 digits. Because there are 4 digits, so replace this b with 4, which means 4 minus 1. It means the highest power here will be 3. So that's why the highest power here is 3. So lastly, I want you to understand that the standard base of any integer is 10. The standard base of any integer is 10. The standard base of any integer is 10. So having known all these key points on that number base, I would like to take you some questions. I will be solving almost about 8 questions that are relating to number base, and then if you can understand how to solve these 8 questions, it means you can solve any questions given to you in your WAEC, in your JAMB, in your GCE. Everything under number base you can solve. Question 1: convert the following numbers to base 10. The first number is 101101 base 2, b 31.24 base 2 from base 4 to base 10, c 101.101 base 2. Now let's start with the first one. Solution: 101.101 base 2. Okay, the first thing to do here is, how many numbers are here? We have 1, 2, 3, 4, 5, 6. There are 6 numbers here, which means the highest power we are going to get is 5 from the first key point I gave to you so this is equals to 1 into 2 raised to power 5 plus 0 into 2 raised to power 4 plus 1 into 2 raised to power 3 plus 0 into 2 raised to power 2 plus 101. Okay, so this is 1 and then this is 0 into 2 raised to power 1, but it's not necessary since 2 raised to power 1 is also equals to 2, then plus 1 into 2 raised to power 0. So this is equals to 2 raised to power 5. 2 raised to power 4 is 16, then 2 raised to power 5 will be 32. So this is 32 plus, this is 0. I don't need to write it because anything multiplied by 0 is also 0. 2 raised to power 3 is 8 plus 2 raised to power 2 is 4. This is also 0 plus 2 raised to power 0 is 1. So 1 times 1 is what? Is 1. So this is equals to, so 8 plus 1 is 9. 8 plus 1 is 9. 9 plus 4 is 13. So 13 plus 32 is will give me 45. 45. So this is 45 base 10. So I've been able to convert 101 base 2 to 45 base 10. So question B. I want to believe you understand what how I solved question A. So I want to go to question B now. 31.24 base 4. So how do we solve this? From my key point 2, I said that the power of this will always be an integer, while the power of this will be a negative integer. This is a positive integer, this will give me a negative integer as a power. So, and then there are two values here. I mean, there are two numbers here. So which means the highest power will be 1. So this is 3 into 4 into 4 plus 1 into 4 raised to power 0. So because this is a decimal point, it means the power here will be a negative sign. So plus 2 into 4 raised to power minus 1 plus 4 into 4 raised to power minus 2. So 3 times 4 is 12 plus 4 raised to power 0 is 1. 1 times 1 is 1 plus this is 2 over 4 plus this is 4 over 4 raised to power 2. I want to take it step by step so that you can all understand. 12 plus 1 is 13. 13 plus this can also be referred to as 1 over 2 because 2 years 1 and 2 years 2, and plus because this is also a power of 1. I can cancel 1 4 and I can get 1 over 4 instead of the writing, so I can just go straight to the point here. So this can give me 13 plus 1 over 2 is also 0.5 plus 1 over 2 is 0.5. 1 over 4 is 0.25. So I can add this together to base 10. Solution. So let's do that now. 101 010 base 2. 1 2 3 4 5 6. There are 6 numbers here, which means the highest power is 5. 1 into 2 raised to power 5 plus 0 into 2 to the power of 4 plus 1 into 2 to the power of 3 plus 0 into 2 to the power of 2 plus 1 into 2 plus 0 into 2 to the power of 0. So this is equals to 2 raised to power 5 is 32. This is 0. This is 8. This is 0 plus 2, and this is also 0. 8 plus 2 is 10. 32 plus 10 gives me 42 base 10. So which means 101 base 2 is equals to 42 base 10. So let's convert the other one. 1111 base 2 is equals to there are 4 figures here, which means the highest power is going to be 3. 1 into 2 raised to the power of 3 plus 1 into 2 raised to the power of 2 plus 1 into 2 plus 1 into 2 raised to the power of 0. So this is equals to 2 raised to the power of 3 is 8 plus 2 raised to the power of 2 is 4 plus 2 plus 1. So this is 8 plus 2 is 10. 10 plus 5 is 15. So which means 1111 base 2 equals to 15 base 10. So we have converted both numbers to base 10. So we are going to replace these numbers with what is in the question. However, 101010 base 2 equals to 42 in base 10. I can decide to clean the 10 because it's a standard base. So 1111 base 2 equals to 15 in base 10. So I replace these numbers with what is in the question. So which means wherever I see this value, I put in 42, and wherever I see this value, I put in 15. So 101010 base 2 equals to x base 10 plus 1111 base 2. So this is 42 equals to x plus 15. So I can decide to add minus 15 to both sides. So therefore 42 minus 15 equals to x plus 15 minus 15, and apparently this one will give us 0. So x equals to 42 minus 15, and 42 minus 15 gives me 27. But 2 minus 15 is 27. So, and since our x is in base 10, which means whatever answer we are getting must also be in base 10. So however, the answer to x is base 10. Question 5. If 32 base x, if 32 base x equals to 20 base 10, find the value of x. So which means we are looking for the base of 32, and this 32 is in base x. Let's change it to standard base, which is in base 10. So 32 base x equals to 3 into x plus 2 into x raised to the power 0. There are two numbers here, which means the x power is 1 and 0. So this becomes 3x plus 2 in base 10. So this is in base 10. So wherever I see 32x in this question, I replace it with 3x plus 2 in base 10. So 32 base x equals to 20 base 10. So because it's a standard base, I decide not to put the 10. So this becomes 3x plus 2 equals to 20. So I can decide to add minus 2 to both sides. So this becomes 3x plus 2 minus 2 equals to 20 minus 2. It becomes 3x equals to 18. So when you divide through by 3, you get 3x divided by 3 equals to 18 divided by 3. Now however, x equals to 6. So which means 32 is in base 6. So if I'm to do my checking, I'm going to equally replace x. I will replace wherever I see x in this equation. Let's say this equation 1. In this equation 1, if I replace x, I'm supposed to get 20. Let's try that. So this becomes 3 into 6 plus 2. 6 times 3 is 18 plus 2, which is equals to 20. So we have the right answer to be 6. So which means x is in base 6.
Start.
Question 6. If x base 2 to the power of 3 equals to 101011 base 2, find the value of x. So I'll always love us to work with standard base. So because this x is in base 2, I will decide not to change it because it's not going to affect our solution. But I will change this to base 10 so that I will be able to find the cube root. It will be easy for me to find the cube root because it's a standard base, so I'll be able to find the cube root. and my solution will be fine. X, so 1 1 0 1 1 base 2. Now find it, to base 10 it's going to give me 1 2 0 1 2 3 4. Highest power is going to be 4. 1 into 2 raised to power 4 plus 1 into 2 raised to power 3 plus 1 into 2 raised to power, plus 0 to 2 raised to power 2 plus 1 into 2 raised to power into 2 plus 1 into 2 raised to power 0. So which is equal to 2 raised to power 4. 2 raised to power 4 is 16. 2 raised to power 3 is 8. This is 0 and this is 2 plus 1. 2 raised to power 0 is 1. 1 times 1 is 1. 8 plus 2 is 10. 10 plus 16. 10 plus 16 is 26. 26 plus 1 is 27. So 101 base 2 times p2 times p in base 2, you can actually multiply it. So when you multiply it, since it's in base 2, you can divide both sides by 101, and then you can divide it, and this becomes 11110 base 2 divided by 101 base 2, and then you can convert to base 10 and then convert back to base 2, whatever answer you get. But if you are sure of yourself and you can actually divide it.
I hope the class was interesting. If you have questions, please drop them in the comment section or send us an email. We will love to help you further. See you in the next class.